In this video, we're going to learn how to convert entire radicals to mixed radicals. What's the difference? So an entire radical is a radical when there's not a coefficient out in front, so when there's not a number multiplied by the radical. One method to converting entire radicals to mixed radicals is finding two numbers that multiply to give 63, and one of them has to be a perfect square because we have a square root of 63. So you can see I have a nice column of the perfect squares on the right over here. It's not necessary that you have a list here, but if you're having trouble remembering what they are, it's very useful to have, and then hopefully over time you'll get to know them pretty well, and then you won't have to have the list. So 63. So two numbers that multiply to give 63 with one of these numbers. Here we have 9 times 7 will work. So we can rewrite this as 9 times 7. That's an equivalent expression to the square root of 63. It's just the square root of 9 times 7. And one of the characteristics of radicals that we learned is now we can rewrite this. We can just divide it up. And instead, that is also equivalent to the square root of 9 multiplied by the square root of 7. And here is the reason why we found two numbers and where one of them was a perfect square. Because now we can take the square root of 9. We know that the square root of 9 is just 3. And then we can't do anything else with the square root of 7. There's no two numbers we can multiply to give 7 where one of them is a perfect square. That's just as far as we can go. So we now have converted the square root of 63, which is an entire radical, into 3 root 7, which is a mixed radical. Make sure that you write your 3 big enough. Sometimes I find a common mistake is students will write the 3 and put it in the index. It is not in the index. It is just saying we have 3 roots of 7, 3 square roots of 7. Okay, let's do another example. So in this one we have the square root of 200. So again, we're looking for two numbers where one of them is a perfect square. And in this one, you can come up with 102. And then just like we did in the previous example, we can divide that up. And we can evaluate the square root of 100 because 100 is a perfect square. So that becomes 10 root 2. Now I am going to show you another way to do this one. It's a longer way, but I just want to show you that it's important. I shouldn't say it's important. It's more useful if when you're finding the two numbers that you find the larger perfect square. Otherwise, you may have to do it multiple times, which is what I'm going to show you right now. And it's not wrong. It's just going to take a little bit longer if you don't happen to, come up with the largest perfect square as one of the factors. So alternatively, we could have chosen 25 times 8, right? So 25 times 8 is also equal to 200, and 25 is a perfect square. So we could have then broken it up like this, and then we would have 5 root 8. Right, so 5 root 8 is also equivalent to the square root of 200. It's also equivalent to 10 root 2, but it's not as simplified as we can make it. So basically, you should always keep going until you can't break up the number underneath the radical into factors where one of them is, a perfect square in this case. And you can see we can still do that here. So we can still have that 4 times 2 is equal to 8. And then we break that up, and you can see 5 times the square root of 4. Well, we know that the square root of 4 is just 2. So 5 times 2 is 10. And then we still have the square root 2 left over. So again, we get the same answer. It just took us an extra couple of steps to get there. Let's do one more, or maybe we'll do 2 more. So the only difference here, we now have a cube root of 108. We're going to go through the same process as we did for the square roots, except this time we're looking for 2 numbers that multiply to give the radicand, so the 108, except this time one of the factors has to be a perfect cube as opposed to a perfect square. So you can see over here in the right-hand column, I have the list of perfect cubes that we can use. So what 2 numbers can multiply to give 108, and one of them is one of those perfect cubes. So 27 and 4 will work. And just as before, we can break those 2 factors up. Just like that. Make sure you continue to put the 3 in the index, right? The index, the cube root does not disappear until we actually take a cube root. So it will in this case for this. So the cube root of 27 is just 3, but then there's nothing we can do with the cube root of 4. So then we just leave it like that, and we have 3 multiplied by the cube root of 4, and that's our final answer. Okay, let's do one last one. So again, same process. We need 2 numbers that multiply to give 128, and one of them has to be a perfect cube, because again, we have 3 in the index. We're looking at the cube root of 128. So we use this list on the right, and hopefully you can see that 64 times 2 is going to equal 128. So then, again, we break it up. We have the cube root of 64 multiplied by the cube root of 2. And from our list on the right, we can see that the cube root of 64 is just going to be equal to 4. And then we can't do anything with the cube root of 2, so we just leave that be. And that's our final answer. We have converted that entire radical, right, which was a cube root, into a mixed radical. It's fully simplified.